All right, welcome. We're going to look at the last free response question from the 10.9 homework packet, okay? Here we go. Let h be a function having derivatives of all orders of 4x is greater than 0. Selected values of h and its first four derivatives are indicated in the table up here. The function h and these four derivatives are increasing on the interval 1 to 3. So based off what I know from what we've done this week, this probably is going to be important for talking about approximations, okay? Write the first degree Taylor polynomial for h about x equals 2. Doesn't sound too bad. I can do that. To write the first degree Taylor polynomial, I need h of 2, which from my table I know is 80. I also need h prime of 2, which from my table I know is 128. All right. I need to do my first degree Taylor polynomial, so p sub 1 of x is going to be equal to 80 over 0 factorial x minus 2, because it's polynomial centered at 2 to the 0, plus 128 x minus 2 to the first power over 1 factorial. Simplifying that out, we get p sub 1 of x is going to be equal to, that'd be 80 divided by 1 times 1, so 80, plus 128 divided by 1, 128 times x minus 2. Okay, so this is my first degree Taylor polynomial for h about x equals 2. I want to use it to approximate h of 1.9. So h of 1.9 is going to be approximately whatever p sub 1 of 1.9 is going to give us, right? And p sub 1 of 1.9 is going to give us 80 plus 128 times 1.9 minus 2, so that's negative 0.1 to the first power, which I don't recommend simplifying. I recommend just leaving it like that, but if you did, you'll get 67.2. All right, so we used our first degree Taylor polynomial to approximate h of 1.9. Now, is this approximation greater than or less than h of 1.9? So is this number bigger or less than the actual value of h of 1.9? Well, what do we know? We want to explain our reasoning too. We know that the derivatives, all these derivatives are increasing. And for this Taylor polynomial, I stopped at the first derivative. I know that all of our derivatives are increasing, which means our next one would be the second derivative. If we want to use an analogy from our tangent line approximations, because this one really is just a tangent line approximation, that means we know that our graph is concave up. And if we stopped just using the first derivative to do our Taylor polynomial, since our next derivative is since the derivative we stopped at is increasing, that means our approximation is going to be less than the actual value. So I know that p sub 1.9 is going to be less than the actual value of h of 1.9 because, and this is how we have to word it, because h prime of x, that derivative I stopped at, that was the last one I used, I know it is increasing. on the interval 1 is less than or equal to x is less than or equal to 3. So because I know the derivative I stopped at is increasing, it means that it's going to have to be inevitably less than the actual value, because the next derivative would give us a more accurate approximation, and the more accurate approximation would be slightly more curved in the right direction, heading upward. All right. Let's take a look at part B. Oh, point-wise here, sorry. Points, you would get 2 points for writing your first order Taylor polynomial. So 1 point for writing out this down here. Sorry, that's 2 points for writing out this down here. And 1 point for your approximation up here, either unsimplified or simplified. And then 1 point for your answer here with your reason that h prime is increasing on that interval. So our approximation is an under approximation. Okay. Moving on to part B. Part B says, write the third degree Taylor polynomial for h about x equals 2. So we want third degree Taylor polynomial for h about x equals 2 and use it to approximate h of 1.9. We're kind of doing the same thing, aren't we? Okay. Taylor polynomial for h about x equals 2. I know that h of 2 is 80. I know h prime of 2 is 128. I know h double prime, because I want third degree, so I got to keep going. H double prime of 2 is 488 over 3. I know h triple prime of 2 is 448 over 3. Sorry, 448 over 3. There we go. Okay, so I have all of my first 3 derivatives of h now at 2, because I'll need that for my third degree Taylor polynomial about x equals 2. So let me write out that polynomial. So this would be p sub 3 of x is going to be equal to 80 over 0 factorial x minus 2 to the 0 plus 128 over 1 factorial x minus 2 to the first power plus 488 over 3 divided by 2 factorial times x minus 2 squared plus 448 over 3 divided by, this is my third term, so 3 factorial x minus 2 cubed. So there is my third degree Taylor polynomial. All right. You can leave it like that. Remember, you don't have to simplify. I am checking my work, just making sure I did everything I need to. You don't have to simplify, but if you want to, you can. I wouldn't recommend it. This is all we need, but if you do simplify, you would get p sub 3 of x is 80 plus 128 x minus 2 plus 488 over 6 x minus 2 squared plus 488 over 3 factorial is 6. 6 times 3 is 18 over 18 x minus 2 cubed, right? That would be the simplified form there. That's 488. It looks a little funny. 488. All right. So that's the simplified form, and then we need to use it to approximate h of 1.9. So h of 1.9 is approximately going to be equal to p sub 3 of 1.9. This is where I definitely wouldn't simplify. This one was technically a calculator problem that year. This is before they switched over the type of how many questions were calculator non-calculator. So you could have typed this into your calculator, but for our purposes, we're just going to leave it unsimplified. Our h of 1.9 is going to be about p sub 3 of 1.9, which would be 80, plus 128 times 1.9 minus 2 is negative 0.1, plus 488 over 6 times 1.9 minus 2 is negative 0.1 squared, plus 488 over 18 times negative 0.1 cubed, and whatever that would give me is my approximation. If you had your calculator, you could find that this would come out to be 67.988. Remember, you don't have to do any simplifying. There we go. This one was 2 points for writing out your polynomial. Here it is. Simplified, it would be right down here. Writing out your p sub 3 polynomial, and then 1 point for approximating at 1.9, which is this, or if you actually worked it out there. All right. So this is the first 2 parts of this for your response question. Please make sure you correct your work and fill out the score report. Bye.